Estuarium. My name is Ariel and I'll be your educator. Today we're going to be learning all about ocean acidification and the bitter future we face due to our carbon emissions. By the end of this video, you'll learn all the ways you can make a difference and lower your carbon footprint.
During the ocean acidification lesson, you'll get answers for questions such as, why are fossil fuels impacting our environment? How is ocean acidification impacting our local shellfish industry? What is pH? How is climate change different from global warming? And what can you do to help our estuaries? What are fossil fuels? Fossil fuels are natural fuels formed in the geological past from the remains of living organisms. The burning of fossil fuels, such as coal, oil, and natural gas, help us do many things. It also transfers carbon from one reservoir to another much faster than it would happen naturally. The combustion of fossil fuels releases carbon into the Earth's atmosphere instantly, which increases the amount of carbon in the Earth's atmosphere rapidly because it builds up faster than it flows into reservoirs. This increase of carbon in the atmosphere is also causing an increase in average temperatures globally. An increase in temperatures causes the melting of glaciers and sea ice, rising sea levels, changes in regional climates and patterns of ocean currents, and have large impacts on people and other organisms. Fossil fuels power the places we live and work, power our vehicles, and help get things like bananas from South America to our local grocery stores. There's no doubt that our current energy system has done a lot of good, but our heavy use of fossil fuels has also caused excess carbon dioxide, or CO2, to accumulate in our atmosphere and in the ocean. All of that CO2 doesn't just stay in the air. The ocean naturally absorbs much of that excess CO2 like a giant sponge. As the ocean absorbs the CO2, it reacts with the seawater, changing the ocean's chemistry. The problem is that as the amount of CO2 in the atmosphere rises from human industry, more is absorbed into the ocean and the acidity of the water rises more than it would naturally occur. The ocean has already taken in so much CO2 over the past 200 years or so that it has become more acidic. This process is called ocean acidification. As of 2006, or the past 260 years, atmospheric CO2 has increased by 36%, and the ocean has absorbed 25% of the CO2. One of the biggest problems associated with ocean acidification is that the ocean gets more acidic. It makes it more difficult for animals to build their shells, which are made out of CaCO3 or calcium carbonate, such as mussels, clams, and oysters. Ocean acidification reduces the amount of calcium carbonate available to the animals in the ocean. It takes more time and energy for shellfish to build their shells, and the shells become weaker. The scale used to measure acidity in the ocean is called the pH scale. Now let's talk about toxins. Persistent organic pollutants, or POPs, are complex carbon-based molecules that do not dissolve in water, but stick to fats instead, and take a very long time to break down into simpler, less harmful molecules. Some examples are organochlorides like DDT, polychlorinated biphenyls, BCBs, or flame retardants including polybrominated diphenyl esters, PBDEs. Personal care, household, and automotive products, and even furniture contain POPs. Because POPs are lipophilic and stick to fat, and because they are generally non-biodegradable, it is difficult for animals to get rid of them. Water-soluble contaminants can easily wash out of animals' bodies through urine. Non-biodegradable, fat-loving chemicals can stay in an animal's body for its lifetime. Think about how an orca whale maintains its body temperature. They have a thick layer blubber, which is dense fat, to insulate them in the cold northwestern waters. Because of this, they are especially susceptible to these types of toxins. Some persistent organic pollutants are naturally occurring, but the clear majority in our waters, Puget Sound and open ocean, come from human industry materials. Examples include cleaning supplies, plastic bags or wrap, plastic bottles, pharmaceuticals, makeup, sunscreen, pesticides, flame retardants, insect repellent, motor oil, paint, glue, and many more. Much of the POPs enter the waterways from cumulative everyday individual actions directly under our control, not just from broad-scale industry activity. These toxins can be bioconcentrated, bioaccumulated, and biomagnified. Bioconcentrated is when toxins are absorbed from the water. Bioaccumulation is the buildup of toxins from the food eaten by one organism over time. Biomagnification is toxins building up between trophic levels through consumption and retention of toxins in many prey animals that had already accumulated their own toxins. Ocean acidification and pollutants can be made worse by climate change. Climate change is a change in weather patterns over time, spanning years, decades, centuries, and even longer. It may be a change in the average number of weather conditions in a region, such as the average temperature in different seasons, or a change in the average number of weather events, such as more or fewer tornadoes or hurricanes. Climate change can be described as a change that occurs across the whole Earth or a specific region. Scientists generally prefer the term climate change rather than global warming. Although Earth is getting warmer, a few parts of the planet may experience cooler weather because of changing ocean currents and other factors. Also, many areas of the planet will experience changes in precipitation and extreme weather events. For this reason, it is more accurate to use climate change as it takes a variety of changes into account. Climate change also encompasses all changes, natural or human-induced. Global warming is used to describe a specific climate change caused only by human-induced increase in heat-trapping gases. As Earth's average temperature continues to rise, it has several effects on both the physical Earth and life on Earth. Sea levels rising, glaciers retreating, and decreasing amounts of sea ice, changing ocean currents, and losing habitats for organisms are just some effects of climate change. So how can you help? Estuaries are the most biologically productive ecosystems in the world, and you're connected to an estuary. Your watershed eventually drains into an estuary, so what you and your family do on land and how you take care of your water affects your estuary. The water that rains on your yard or goes down the drain at your house ends up in the estuary. If you visit a beach on the Puget Sound, your actions can affect the estuary as well. Whether you are right in the middle of an estuary or miles upriver, your actions make a difference. Here are some actions you can take to help your estuary stay healthy. Preserve forests, recycle and use less paper, turn lights off, adjust the thermostat, plant a tree or garden, walk or roll or bike to school, recycle plastic, buy in bulk or use less packaging, bring a reusable shopping bag, use rechargeable batteries, eat less meat, buy used instead of new, eat locally grown food, recycle your e-waste, unplug electronics when you aren't using them, replace incandescent light bulbs, use wind power or solar power, turn off your vehicle, use public transportation, go pesticide-free in your garden, and wash your car where runoff will be cleaned before entering the waterways. About a quarter of the carbon dioxide emitted into the atmosphere from the burning of fossil fuels ends up in our ocean. Carbon dioxide causes the ocean to become more acidic, which is represented by lower pH. Even though the ocean waters aren't acidic, a small shift in this balance in pH can make a big difference for the survival of organisms. Now I'm going to do a short demonstration that shows what happens when we don't change our ways and continue to produce more CO2 that causes ocean acidification in our waters. First, we need to make salt water for our ocean. 1 liter of fresh water to 35 grams of salt. Now we add our salt water to the jar. Next, we'll be adding pH indicator to dye our water to tell us what the pH is. We'll be adding about 10 drops. Swirl it to make sure the pH indicator is all incorporated into the water. We're going to use a universal indicator color chart to see where our water sits on the pH scale. Our salt water is currently at an 8, which is normal range for our salt water. 7 is neutral or fresh water. Ocean water sits anywhere between an 8 and a 9. We're going to use a soda stream to add concentrated CO2 into our salt water. This is just like the ocean soaking up all of that CO2 from our atmosphere. You can see our ocean water has changed from the CO2. Where does our new ocean water sit on the pH scale? About a 6. Remember, our original ocean water was sitting at about an 8. We moved all the way to a 6 on the pH scale. To move on the pH scale from an 8 to a 6 means our ocean water is 100 times more acidic from the original. To move from an 8 to a 7 is times 10, and from 7 to 6 is another times 10. Remember, by changing your everyday habits can help lower your carbon footprint.
Thanks for joining us today. If you liked our video, give us a thumbs up. And if you wish to continue to get more of our videos and other education materials, please subscribe to our channel or follow us on Facebook at the Puget Sound Estuarium. Bye!